Welcome to solverfy.
Okay, so for part A, we want the transition from 3 to 2. So we know the change in energy from 3 to 1 is 4.854 times 10 to the minus 17 joules. And we know the change in energy from 2 to 1 is 4.098 times 10 to the minus 17 joules. So it's the 1. So our change in energy from 3 to 2 is going to be the change in energy from 3 to 1 minus the change in energy from 2 to 1. So basically, we're going to be doing this number minus this number. And so our change in energy from 3 to 2 ends up being 7.56 times 10 to the minus 18 joules. And so we also know that this is going to equal hc over nu. So if we rearrange this equation and we plug in Planck's constant and the speed of light in a vacuum, then our wavelength for the 3 to 2 transition comes out to be 2.63 times 10 to the minus 8 meters. So this is all for part A. Now for part B, we're going to do the same thing. So we want the transition from 4 to 1. And that's going to be the transition from 4 to 2 plus the transition from 2 to 1, the energies, changes in energies. So we already know these two values that you can get from the actual question. And so the change in energy from 4 to 1 comes out to be 5.122 times 10 to the minus 17 joules. And again, we know the change in energy from 4 to 1 equals hc over nu. And so, sorry, not nu, over lambda. So lambda, 4 to 1, is going to be Planck's constant times the speed of light in a vacuum divided by what we just found here, 5.122 times 10 to the minus 17. So we end up getting lambda to be 3.88 times 10 to the minus 9 meters. So that's our wavelength from 4 to 1 for part B. For part C, we want the change in energy from 5 to 4. So that's equal to the change in energy from 5 to 1 minus the change in energy from 4 to 1. And so again, you can find these values in the question. And so the change in energy from 5 to 4 ends up being 1.2 times 10 to the minus 18 joules. And that is also equal to hc over lambda. So again, plug in Planck's constant, plug in the speed of light in a vacuum, solve for lambda, and you get lambda to be 1.67 times 10 to the minus 7 meters. So for part A, your wavelength is this. For part B, your wavelength is this. And for part C, your wavelength is this.